Hi, good day everyone. My name is Antoinette Stepahano from BSE C3A, and for today's video, I'm going to perform task number 7 in EC 36, and that would be all about infrared remote control. So just a quick definition, infrared receiver or IR receiver is a hardware that sends information from an infrared remote control to another device by receiving and decoding signals. And in general, the receiver outputs a code to uniquely identify the infrared signal that it receives. These devices pick up infrared signals from my remote control, just like TV or cable box. And after receiving an IR signal, they encode and amplify it to be suitable for transmission via low voltage wiring. So let me show you here the instructions and the requirement. So you need to perform experiment number 7. So that will be infrared remote control. Second, you need to study and familiarize on how to configure and use the infrared receiver with the Arduino. Third, I may need to integrate the IR remote control function to my level number 2 task, and that is about Max 7219 8 by 8 LED dot matrix. So since I was assigned for that, I may need to add two remote control functions. That will allow me to reset and play and pause continue your scrolling animation by just using an IR remote controller. So I may need to assign two buttons for the appropriate key on my remote for this function. So the content would be, first is the schematic diagram, second the construction procedure and materials, third is the programming codes, and the final output. So first we have here the schematic diagram, and I created this in the fixing application. We have the IR receiver, the MAX 7219 8 by 8 LED dot matrix, and the Arduino Uno. For the VCC, that it's 5 volts for Arduino Uno connected, and data in will be the pin number 6. The digital pins for the Arduino Uno, the ground will be the ground, and last, in second one, we have here VCC and the ground, which is connected to 5 volts for VCC and ground for the and the data in, which is connected to 12, and the chip select connected to 11, and the clock is connected to number 10, or pin number 10 in our digital pins in Arduino. All right, so we have here the materials that I've used. So first we have the infrared receiver. I have two types, the one which is directly connected later to the Arduino, which comes with the connecting wires already, and this one which is connected to our breadboard, and then we'll connect that to Arduino to generate the hex. And of course, the remote control, this one. And second, the MAX 7219 8 by 8 LED matrix. So this is the LED dot matrix. So there it comes with the connecting wires as well that will be directly connected to our Arduino later. And we have the Arduino Uno R3, which will be used. And the last will be the connecting wires, of course. These are the connecting wires. And the power source. I've used this battery, which is 9 volts, comes with the connecting cable. And of course, the breadboard that comes with this type of infrared. We have here the code that we'll be going to use to generate the hex or the button that we need to assign for our task number 7. So of course, it comes with these wires. So this first wire, the red one, will be connected to our VCC, or this is the VCC connected to 5 volts. Next, we have the orange one, the middle one, the middle pin of this IR. So that will be connected to the ground. And then we have last one is the data or the output will be connected to pin number 6. So this is how it looks like. Right. Now we may need to input or plug in this to our Arduino Uno. And then this is the remote that we be. So we need to focus to the serial monitor, but we need to delete this so that will work. Right. So let's start. Let me just connect this one. The Arduino. All right, that's already connected. So we'll just use this remote. So I'll just push 1 and 2. So for 1 and 2, let me just upload this code first. Let me assign the Okay, all right, done uploading. So let me just open the serial monitor for us how the code created. So let me push 1 and then 2, a little bit faster. So this is the hex code for the button 1. Let me repeat. I already repeat 1. So once if you press it too long, it will show a letter F. Let me press it faster. That's the hex code. We'll just copy paste it later. So second, we have the button number 2. Button number 2. Now I have here the final code I'll be from my final output. So of course, let me just remind you what we have did earlier. So this is the text code that we generated to the first code that we programming code that we have. So this one will be hex for the pin number 2. I mean button number 2. For button 1, that will be play and reset. For button 2, that will be pause and continue. Now let's move forward. So I have here the code. And first is, of course, I included the LED control because I'm using LED matrix. So for the data in is pin 12. For the chip select, that will be pin 11. And clock pulse will be pin 10. So for the receive pin for my IR remote control or IR receiver, that will be pin number 6 in our Arduino. So the matrix, of course, is only 1 because I just buy frame array. And this is only included for 1. I mean, considered 1. And second part here is, of course, the assign button. So as you have remembered, so these are the code, text code. So I did copy paste this for the play and reset. You see here. For the pause and continue, use this one, which is just this, right? And I just did assign bool control for the opposite function for the reset and continue. So initially, this is play and this is pause. And this bool control will determine the reset continue. And then I assigned the result. Of course, repetition is 20 will be multiplied to 10, so that will be 200 milliseconds for the delay. So the frame count max that we have starting from 0 is 120 in total. This is 120. And this is the void setup from here up until here. And then this is the void loop. And I did just put in a display frame and also for the display for the void red report for us for the remote control to read the code that is assigned. And yeah, that's it. That's for delay. Number 10 multiplied to 20, which is the repetition. So that will be a total of 200 seconds for the delay of my frame array. And now let's upload this code, or let me just compile it first. All right, done compiling. So we may need to upload that, but I'm going to first create or plug in this material. So first we have the MAX 7219. So I'm going to input that. For the clock will be pin number 10 as was assigned here. So clock is starting from the color green to orange. So considering this pin 10 and pin 12. Okay. And next we have, of course, the VCC for 5 volts and ground for the red one, since the ground is color red in our what it looks like. Now let's input our remote control receiver. This is a receiver that I've got that will be directly connected to our Arduino. So first, of course, let me tell you this is the signal pin, which comes with S. The positive sign will be for VCC and negative sign will be for the ground. So of course, color blue will be connected to ground since that is negative sign. We have the violet for the 5 volts and then the white one for receiver or pin number 6. So that's how it looks like in my connection. So it will be much more clean to look if it will be directly connected to our Arduino aside from doing it on a breadboard. And this is the remote control. So later I'll show you how to control this using the remote control. And then let me just input this first, plug it into our Arduino. So since we were able to connect everything here, we have the MAX 7219. And this is how it Now let's go ahead and upload this code. Do what it did, check everything and plug in everything. When we uploaded, that's how it's down. And initially it will show that one because I did already program it earlier. But anyway, moving forward, let me just upload this. Make sure first that the port is corrected from 4. That is where it is. Now let's go ahead and upload it. Right. We have seen already lit up here. Done uploading. So let me just open the serial monitor for you to see that I have it correctly. So let me press 1 because this is the play, so that it will start. Got it. That's how it looks like. Perfect. Okay, let me just hold it for you. That's what you can see. Now let me reset. Go back to the function. Let me play. Then reset and then let me play. Then reset and then let me play. Yeah, you got a pin button 1. So also pin number 2, let me pause and then continue. Let me pause and then continue. That's how it works. So we were able to also see that in serial monitor where the code that is right. Okay. That's it. Now let me just try that with the power source, which is battery. So for battery, we have here the 9 volts battery. So for the 9 volts battery, we'll just need to connect this here, the power source, then just maybe. Now let me try again. So one button will be the play. All right, it plays. And then when you press again the button 1, it will go back. And then play. So initially, we need to press the first or the one or the button 1 in order to play it. Once you reset it, press the button 1. Now let me try button 2, pause, and then pause, continue, and then pause and continue. All right, so that's how it works for this task number 7, and this is my final output. Now, I guess that ends this video, and I hope that you've learned something for today, and we'll see you on the next video. Goodbye.